Hi, and welcome to day one of sequences in series. All right, part one is arithmetic and geometric sequences. The objective is to identify an arithmetic or geometric sequence and find a formula for its nth term. A sequence is a set of numbers called terms arranged in a particular order. We will begin with two of the simplest types of sequences, arithmetic and geometric. An arithmetic sequence is a sequence of numbers. A sequence of numbers is called an arithmetic sequence if the difference, which means you subtract when we have difference, of any two consecutive terms, consecutive means two in a row, is constant. This difference is called the common difference. This is very important, the common difference. The following sequences are all arithmetic. So if I have 2, 6, 10, 14, 18, my common difference is 4 because the difference between 6 and 2 is 4, and 10 and 6 is 4, and 14 and 10 is 4, and 18 and 4 is 4. 17, 10, 3, negative 4, negative 11, negative 18, my common difference is negative 7 because 10 minus 17 is negative 7, 3 minus 10 is negative 7, negative 4 minus 3 is negative 7, and so on. My last one, I have A plus D, A plus 2D, A plus 3D, A plus 4D. My common difference is D, because I just keep adding one more D to everything to get my next term. A geometric sequence. A sequence of numbers is called a geometric sequence if the ratio, remember a ratio is a fraction, of any two consecutive terms is constant. This ratio is called the common ratio. Again, that's going to be important. The following sequences are all geometric. All right. So I have 1, 3, 9, 27, 81. My ratio is 3. 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. And 81 divided by 27 is 3. 64, negative 32, 16, negative 8, 4. My ratio is negative 1/2. Negative 32 over 64 is negative 1/2. 16 over negative 32 is 1/2. Negative 8 over 16 is 1/2. Negative 1/2, excuse me. And 4 over negative 8 is 1/2. And I have AR squared, AR cubed, AR to the 4th, and my ratio is just R. The same notation can be used for all types of sequences. The first term of a sequence is often denoted by T sub 1. Sometimes you'll see A sub 1 as well, depending on the book you use. The second and third terms by T sub 2 and T sub 3. Could be A sub 2 and A sub 3. And so on. The nth term of a sequence is then noted by T sub n. Some sequences can be defined by particular rules or formulas. If you have a formula for T sub n in terms of n, you can find the value of any term of a sequence. For example, suppose a sequence has the formula T sub n equals n squared plus 1. If I want to find the first term, I just substitute 1 in for n. So 1 squared is 1, 1 plus 1 is 2. And then I'd have substitute in 2 for T2. So 2 squared is 4 plus 1 is 5. Then put in 3 for n. 3 squared is 9 plus 1 is 10. Then put in 4 for n. 4 squared is 16 plus 1 is 17. And so on. So my actual sequence would then be 2, 5, 10, 17, and so on. Note that sequence is neither arithmetic or geometric. If we look back at it real quick, there is no common difference. Here when I subtract I got 3, here when I subtract I get 5, here when I subtract I get 7. If I divide I'd get 5 halves, and then I'd get 10 fifths, which is 2, so 5 halves, 2, and then 17 tenths. Okay, not the same value. So therefore it's neither geometric or arithmetic. Formulas for the nth term of a general arithmetic and geometric sequences are given below. Notice how similar these formulas are. So my formula for, let's see, my formulas for the arithmetic sequence are t sub n, that's to get the nth term. It's equal to t sub 1, which is the first term, plus n minus 1 times d. And then what you're doing is you're adding the difference n minus 1 times. A geometric sequence is t sub n to get the nth term. I take t sub 1, which is the first term. Okay, I always need the first term here, times r to the n minus 1. And you're going to multiply by the ratio n minus 1 times. So the two formulas are very similar. I do not believe that either one of these is given to you on the Regents exam. So you would have to remember these formulas. All right, the definition of a sequence. In mathematics, a sequence is usually defined to be a function whose domain is the set of positive integers. For example, the sequence with the nth term, t sub n equals 4n minus 2, can be thought of as the function t of n, 4n minus 2, where n is a positive integer. So for example, find a formula for the nth term of the arithmetic, it means I'm going to have a common difference sequence. Use the formula t sub n equals t sub 1 plus n minus 1 times d. For this sequence, t sub 1 is 3 because that's my first term. Okay, t sub 1, 3, plus n minus 1 times d. The common difference is 5 minus 3 is 2. I could also do 7 minus 5. And I still get 2. It's always second minus first, third minus second when you're figuring out your common difference. So then I put a 2. Then I just simply distribute my 2. So I'll get 3 plus 2n minus 2. Combine like terms, 3 and a negative 2. We get 2n plus 1. So I could find any term in this sequence. Find a formula for the nth term of the geometric sequence 3, 4.5, 6.75. Use the formula t sub n equals t sub 1 times r to the n minus 1. In this case again, my first term is 3. And the common ratio is 1.5 because r is equal to 6.75 divided by 4.5. And you just divide that out and you would get 1.5. I could have used 4.5 divided by 3, and that would have given me 1.5 as well. To be honest with you, the reason I didn't use that is because if you subtract 4.5 and 3, you'd get 1.5, and I didn't want you to think that I subtracted to get my common ratio. I need to actually divide. And again, it's second divided by first or third divided by second. So t sub n times 3 to the n minus 1. And just something that you need to remember, when you multiply, you add exponents. And negative exponents go in the denominator. I'm going to be using these properties to help me simplify. So I have 3 times 1.5 to the n times 1.5 to the negative 1. I'm just taking my bases here, and I'm taking in, if I were to add those two, I'd get n 1.5 to the n minus 1. And I'm kind of breaking them up into its parts. Now I can take my negative exponent and then throw it in the denominator. So I get t sub n is equal to 3 times 1.5 to the n over 1.5 to the first. I'm going to bring out that 1.5 and put it underneath the 3 because this is a 3 over 1 and I'm multiplying. And I want to get my exponent all alone. 3 divided by 1.5 is 2, and then I have 1.5 to the n. So this is my formula for the nth term. It'd be 2, 1.5 to the n. So in a geometric sequence, t sub 3 is equal to 12, and t sub 6 is equal to 96. Find t sub 11. So what I've done is I have two terms, and I want to find the third term of the sequence. They tell us it's geometric, and because it's geometric, I have to use t sub n equals t sub r 1 times r to the n minus 1. And in doing that, I can find some values here. I can find t sub 1 eventually. So my third term is going to be t sub 3, my first term times n minus 1, the r squared. And that is equal to 12. So n is 3. That's where this t sub 3 comes into. N minus 1 is 2. That's where that 2 comes from. Now my goal would be to get t sub 1 alone. In order to get t sub 1 alone, if I look down here, I would just divide by r squared, and I'd have t sub 1 equals 12 over r squared. Then I have t sub 6, and that's t sub 1 times r to the 5th. That's 96. So again, n is 6. N minus 1 is 5, so now we get t sub 1 alone. Now we can set them equal to each other. 12 over r squared equals 96 over r to the 5th. And we can cross multiply. And when I do that, I would get 12r to the 5th equals 96r to the 2nd. And let's see here. Okay, sorry. My goal is to get the r's to one side and the constants to the other side. So I divide both sides by r squared and divide both sides by 12. And I'll end up with r to the 3rd because the 12's cancel out. And in here the r squareds cancel out, and so I get r to the 5th divided by r to the 2nd is r cubed, and 96 divided by 12 is 8. Take the cube root of both sides, so r is equal to 2. So I know what r is equal to. Now I have to find t1. So we just use one of our formulas. It doesn't matter which one we were using. I went back to t sub 1 equals r squared times equals 12. So t sub 1 times r squared, well, r we found was 2. 2 squared is 4. 12 divided by 4 is 3. So my first term is indeed 3. Since t sub 1 is equal to 3, we can now find t sub 11, because the problem actually asks us to find t sub 11. So t sub 11 is equal to t sub 1 times r minus 10. So remember, n is 11, so n minus 1 is 10. And t sub 1 is 3, so I put 3 in place of t sub 1. 2 to the 10th, I do 2 to the 10th on my calculator, I get 1024. Times 3 is 3072. Alright, and what I want you to do is put a smiley face on the bottom right hand corner of page 3 in your notes. In class, we will be trying some exercises here on the next page. Alright, so that's it for day 1.